Hello students, today we will see the continuation of the introduction part of Python programming. So here we are going to start with programming languages. So what is a programming language and how the history of programming languages evolved. Everything we are going to start with, right? So what is first we will see what is programming language. So computer programs known as software or instructions that tell a computer what to do is known as a programming language. So we are giving some instructions to the computer, so that instructions will guide the system what it has to do, right? So that is what known as programming language. So we will start with the content now. So first type of programming language is represented as machine language, right? So this is what the machine language, first one. So in this machine language, it is directly executed by the computer, right? So that is why it is named as machine language. It can be understand only to the computer, and it is difficult for the human to understand. So a computer native language, which is known as machine language, is given here. For example, if you want to add two numbers, that instructions may be, for example, we are giving the instructions as ones and zeros. So the any instructions that is represented as ones and zeros is known as machine language, right? So for example, you can consider this ones and zeros is the instruction that is given to the computer to add two numbers. For example, you can give 3 plus 4. This is the instruction to add 3 plus 4 to give the value of 7, right? So that is what machine language, but a human cannot interpret from this ones and zeros what this instruction specifies. Only the machine can understand. And that too, the machine language differs from different types of computers. If you are using different types of computers, the machine language is also differs. That machine language difference is based on the computer architecture, how the computer is built, right? So that is what the computer architecture is. Okay, now next we will start with assembly language, which is the second type of programming language, right? So assembly language uses short descriptive word known as mnemonic, right? So it uses short descriptive word which is known as mnemonic. That is what given here. So mnemonic is nothing but we are giving, for example, if you want to add two numbers, if you see this instruction, it consists of only ones and zeros. But if it is mnemonic, you will give a short description as add, because we are doing addition here, right? So add A, comma, B, right? So that is what we can write it here. Add A, comma, B. So this implies A is equal to A plus B. Normally in assembler, we will represent that A as an accumulator. So whatever value it is storing, so it both will be added, and once again the added value will be stored in A. Right, so that is the procedure of assembly language. We will add A and B. For example, we can store the same value as we have given before. 3 will be in A, and B will have 4, and these 3 plus 4 will be added, and that will be stored as 7 in A. Right, so this is what assembly language. And here we need a system software. Already in the previous class I have discussed about system software. So why we need a system software? Because we are giving the instruction which is represented using short descriptive word known as mnemonic, that can be understandable only to the humans but not the machines. So if the machine wants to understand this, it needs assembler to convert the given mnemonic to machine language, right? So that is what assembler job. So it is a system software, right? It is a software which converts. Assembler is a software which converts. That is what given here. It is a software that converts assembly language into machine language, right? AL to ML, that means assembly language to machine language. So that's all about assembly language. Next, we will move on to high level language. So Python is one of the high level language. Like this, we are having so many number of high level languages that are available like Java, Python, etc. Right? So here a new generation of programming languages known as high level languages or emerged. They are platform independent. That means you can execute the same program in a Windows operating system as well as in Linux operating system or Mac operating system. All will give the same output. That is what platform independence specifies, right? So which means that you can write a program in a high level language and run it in different types of machines. That is what we have discussed. So it can be a Windows or Linux operating system. For example, in a high level language statement that computes the area of the circle with radius 5, then this is the instruction, right? So we will stick on to the previous example so that we can write A is equal to A plus B, right? That means A will be added with B and once again the result will be stored to A, right? So this is the high level language. So if you see the difference between the previous machine language instruction for adding two numbers and assembly language instruction for adding two numbers and finally high level language instruction, right? So that's all about the introduction about so introduction about Python already we have seen. This is the introduction about language, right? So how the history of language has developed from machine language to high level language, right? Next we will move on to the while we are representing the high level language, here as we have said before in assembly language we need assembler which is a system software to convert the assembly language to machine language. Similarly, in high level language, we need a system software that needs to convert the high level language to machine language. So that system software is either it can be an interpreter or a compiler. Already in previous class, I have given some introduction about interpreter and compiler. So same concept is discussed here. So what the interpreter will do, so whatever program we are writing in high level language is known as source program or source code, right? So it can be, so source code will be given as input and what the system software, so if it is an interpreter, what it will do, it will execute the source code and it will generate the output. And if it is a compiler, right? If it is interpreter, it will execute and generate the output. So source code will be given to the compiler. So it will generate a object code, right? So what if the source code is generated as object code, then that is known as compilation, right? And after the object code is generated, once again we have to execute this object code, right? So execution takes place. So this is known as execution phase, right? So this will give the output. So here there are two phases if you are using compiler as a system software, and if it is an interpreter as system software, it's a single phase which is the execution phase. If it is compiler, it consists of two phases. One is compilation phase and another one is execution phase. Right. So that is the difference between interpreter and compiler. So as I said earlier, Python uses interpreter. Python high level language is an example which uses system software as interpreter to convert the given language to machine language. And one more thing for interpreter, it is a line by line execution. If there is one error in a particular line, then it will not identify the errors in the next forthcoming lines, right? So that is what represents line by line execution. So next comes compiler. So in this compiler, example for compiler is Java, right? So that means source code will generate the object code while compilation phase, and once again you have to execute the object code to generate your output, right? So Java is an example program high level language which uses compiler as a system software. right? So it is while you're generating the object code, the entire code will be identified for errors, right? It will not do line by line error checking. It will do full source code error checking. Okay, so that is what given here. An interpreter reads one statement from the source code, translate it to the machine code or virtual machine code, and then it executes it right away. Similarly, a compiler translates the entire source code into machine code file, and the machine code file is then executed. Right, so that's all about the introduction part of programming languages. Then we will move on to the second topic of Unit 1, which is setting up Python in operating system, as well as how to execute the files using Python IDLE, right? So IDLE is nothing but integrated development environment. So instead of writing coding in commands, instructions in commands, we will use this integrated development environment, which will provide a user-friendly environment to execute your code, right? So IDLE stands for Integrated Development Environment. Right. Okay. Now we will start with the setting up Python in operating system. So first we will see for Windows how it works for Windows. So you can use this particular link to download a Python program in your Windows operating system. Right. So here it is from python.org website and downloads. If you click on this link, automatically the current available version is 3.12.1, and you can start download it and start installing it, right? So once you have downloaded, it will be in an exe file and you can install. And while you are searching for this IDLE, automatically it lands in shell mode, right? So there are two different of execution in Python programming. One is shell mode and another one is script mode. So shell mode, you can execute only one instruction at a time in a shell mode, right? So this will be the prompt which will be available while you are in shell mode, right? That is what given here. And if you want, so shell mode, as I said earlier, you can execute only one instruction at a time. Once you have given enter, automatically it will go to the next line for to get your next instruction. But while when you switch off your operating system or you switch off your computer, automatically whatever you have done in the shell mode will not be available for next use, right? So that is the disadvantages of shell mode. You can execute currently and you can verify the output, but you cannot save it and use it later. But in script mode, the Python code will be written in a file, right? And that file will be executed, and that file will be executed and you will get the output for the corresponding file, right? So that is known as script mode. And for working with script mode, you have to go to the file menu, new program, click write a Python program here, and after that you have to click run menu, which will run the script mode, right? So after that you can save it and do all these operations in that script mode, right? So this and all I will show you by giving a demo. Next comes Linux operating system. So by default, Linux will have the Python, right? So no need to install, as I said before, for Windows operating system. You can directly start working with Python, right? So what you have to do, you have to go to terminal and you have to type Python over it. Automatically, it will land in shell mode. Right, so we know what will be the prompt that representing the shell mode. The prompt representing the shell mode is 3 greater than symbol. So next comes terminal. Next comes script mode. As I said earlier, so this is what the script mode is, right? So this is represented as script. So in the terminal itself, you have to open a editor. So there are so many number of editors available in Linux operating system. VI editor, VIM editor. Similarly, we are having Nano, gedit, right? So these are some of the editors that are available, and using that editor you can type the Python program, save it and exit, and you have to execute this file. For example, if you are giving the file name as hello.py, then how you have to execute it? You have to execute it as Python space hello.py, right? Automatically, if you click on enter, you will get the output of this particular file. And this is reusable even though your system is shut down, because it is in a file format. You can once again open the file content, and you can once again make changes and execute it. Otherwise, you can reuse it whatever you have done previously, right? So that is the difference between script mode and shell mode. Script mode, one instruction at a time, and after that you have to give the next instruction. And one, it is volatile. That means once it has been uh, switched off or shut down, automatically the commands what you have typed will not be available. But in script mode, it will be stored in a file format, so you can reuse it when you are coming back, right? So these are the two methods of executing Python programming. Now we will start with the demo of Python programming. Okay, so this is the shell, IDLE shell, which we are representing here, right? If you see the shell, automatically it consists of menus like file, edit, shell, debug, options, window, etc. Right? And if you go to the file menu, automatically it will show what are the menus that are available: new, open, uh, open module, recent files. So if you click on, so once this IDLE is open, it will be landed in the shell mode, right? So can you able to see the shell mode? It is available, right? So it will be landed in the 3 greater than symbol. So you can type the instructions line by line. And if you want to go for the script mode, click on this and then click on new file. A new window will be opened. So I will open that window also. Right. So a new window will be opened, and you can just type print hello. Right. So just I am typing print hello, and I am saving this file. File save, and then I am giving the name as hello.py, right? And then I am giving save, right? So after that, what you have to do, you have to click on the run option and then click on run module. Automatically, it will run in this shell prompt, right? So I will show the shell prompt also, right? So if you see here, can you able to see how this hello.py is executed? Now it is showing the representation as hello, right? So can you able to see the output? Output is represented as hello here, right? So this is how you have to work on shell mode or script mode in Windows operating system. So the same thing I will do it in Linux operating system also. So instead of Linux operating system, here I have used Anaconda prompt. So I will go to the Anaconda prompt. So Anaconda is also one of the tool which is used to show the whatever applications which are available, IDLEs which are available to execute your Python program, right? Okay, now I'm going to show that Anaconda prompt. Okay, this is the Anaconda prompt, right? So So Anaconda prompt, I think it is not available here. Actually, how you have to represent it. So I will show it in the Word file how you have to represent it. So you have to open this Anaconda prompt and you have to type Python over here. So this will be available like this, right? So I will show it here. Just I am copy pasting what is available in the Anaconda prompt. So I don't know why it is not displaying in this terminal point. I have selected terminal, but now I will show it in a Word file. So I have selected that Word file. If you see here, this is how the terminal will look like. So if you give Python, automatically it will land in 3 greater than symbol, and if you give exit, it will exit it, right? Similarly, you can type what I have specified earlier as python space hello.py. It will execute in the Linux. So the difference is in Linux it will be inbuilt, but in Windows you have to install it, right? So that is the difference, right? Thank you.